We're learning about solutions, and in order to do the things in this unit, you need to know about three kinds of ways of measuring concentration. Measuring concentration. Okay, so if I were to ask certain students in here about what this unit was about, I bet you could think and look around the room and figure out who could actually answer that question. Well, that's a different kind of concentration we're talking about here. The concentration we're talking about here is about the concentration of a solution. Concentration of a solution. Okay? So you can think about it like this. How many of you like really sweet tea? Okay? Really sweet tea has a high concentration of sugar. How many of you prefer to have tea that doesn't have a lot of sugar in it? Then you like a weak concentration of sugar in your tea. Okay? Like me, I don't like to have a whole lot of sugar in mine. Huh? I am. I was born and raised. Where? South Georgia.
Wow. Oh my God.
Well, there we go back to that concentration thing, right? Okay.
That was a joke.
Quiet, please. All right. So in this unit, there are a lot. Well, first of all, let me say this: there are lots of ways of measuring concentration. Lots of ways of measuring concentration. But in this unit, you're only going to be expected to know of three and do calculations with three of them. Okay? And the first of those three is called molality. Molality. Yep. What about okay. Okay. Molality. All right. Molality has the symbol small letter M. Yes, it has a lot to do with moles. Okay, so molality, and as in all concentrations, are a comparison of two different measurements. All concentrations are a comparison two different measurements.
It's a lowercase m, right?
Lowercase m. Okay? Two different measurements. So molality is moles of what's called the solute over kilograms of the solvent. Moles of solute over kilograms of solvent. Now, I'll give you the definitions of these in a minute, okay? We'll talk about them. Okay? Good for you. Okay. Then the second unit of measurement for concentration you need to know in this unit is molarity. All right, so spelling is going to be pretty important for these words, isn't it? Yeah. Only one letter differentiates them. Now, molarity, the symbol for molarity is a capital M. Now, some of you have some pretty sloppy handwriting. Okay? And it's hard to tell your capital M's from your lowercase m's. Okay? And that's the case with a lot of chemists. Chemists are right next to doctors having bad handwriting. So in order to make it clear that this is a capital M, here's how chemists have decided to handle the problem. All the capital M's that stand for molarity are underlined whenever you're writing them by hand. Now, if you're typing on paper, a capital M is fine, but if you're writing them by hand, you write them with a line under it. Okay? You do have to do that. It doesn't matter. You have to do it in here. In here, you're a chemist. Okay? All right. Molarity. Remember, all concentration units are compare two different measurements. Okay? Molarity is moles of solute on the top, but on the bottom it's liters of solution. Liters of solution. Okay? Liters of solution. Okay?
Are you okay, sir?
No.
All right. And the last one that you have to know and be able to do calculations with is called percent concentration. Percent concentration. And what goes on the top of that is the mass of the solute over the mass of the solution. And since it's a percent, we're going to multiply that by 100. Okay? Mass of solute over mass of solution times 100.
Oh, that first one, is that molarity? What is it?
Moles of solute over kilograms of solvent. Moles of solute over liters of solution.
The word. The word.
Yeah, is it molality or is it molarity?
Molality. All right, let's look at a few terms then. Solute. Okay, since y'all discussed this, Todd, in biology, you remember what solute is? Yes, that's a good definition, the thing that's being dissolved. Solvent can be thought of as the thing that's doing the dissolving. So solute is the thing that gets dissolved. Solvent is the thing that does the dissolving.
Don't correct me. I did a good job, sir.
Okay, and then we leaves us with solution. And the solution is the solute and the solvent together. The solution is the solute and the solvent together. Amber, you need to focus here.
I'm sorry, I distracted. Sorry.
Skylar, you need to focus up here, please. Okay? Everybody got that? Solute gets dissolved. Solvent does the dissolving. Solution is both of them. Okay? Solute is the thing that gets dissolved. Solvent is the thing that does the dissolving. And the solution is both of them together. Okay. Has anybody ever put so much sugar in their tea they couldn't get it all dissolved? Okay. Orange cereal. Okay. So you stir and you stir and you stir and still there's some sugar at the bottom, right? Okay. If you have dissolved as much of a solute into a solvent as you possibly can, that's called a saturated solution. Okay? If you have dissolved as much of the solute as you possibly can into some solvent, that's called a saturated solution. That's called a saturated solution.
Wait, you thought you said
No, I said it was a saturated solution.
Wait, okay, then what's unsaturated?
I haven't gotten to that yet. Just hold on.
Yeah, because the ear confused.
Just hold on.
What are y'all doing?
Can you repeat saturated?
It's too much going on.
All right. Do you really want to stay after school the first day back from Thanksgiving? Find a way to button your mouth shut and keep your hands and feet where they belong. Yes, Jessica. A saturated solution the way I described it before was if you have put as much solute as you possibly can in the solvent, then you have a saturated solution.
Solute in solvent?
Yes. Solute in the solvent.
Much solid.
If you have dissolved as much solute as you possibly can in a solvent, then that is a saturated solution. Okay?
Have you already said unsaturated?
No. An unsaturated solution then is any amount of solute less than that.
Any amount. Which one is it again?
Unsaturated is any amount of solute less than that.
Could you say less than saturated?
Yeah. And then we have this strange term called supersaturated. Supersaturated. And supersaturated occurs when you trick the solution. Supersaturated occurs when you trick the solution or the solvent into dissolving more solute than it ought to.
Dissolve more. When you trick the solvent into dissolving more.
Than it ought to.
How do you do that?
Well, it actually depends on the solution.
What do you mean by trick? Hold on.
Yeah, come back here.
Get a receipt.
I said that, not you. Don't play me, Shane, because I said that. I'm not playing. Stop playing.
Where the button?
Okay. Guys,
Ow! I thought he said in your ear.
you don't have a short memory. What did I say a moment ago about disrupting the class? You're going to have to spend class.
After Thanksgiving Monday.
Am I not clear? Alec? All right, what I have here is a solution of something known as sodium acetate. Sodium acetate. So this is sodium acetate. Sodium acetate. Okay, now what's in this bottle right here is also sodium acetate. Okay, so I dissolve sodium acetate in here, and this is still the dry powder crystal form of sodium acetate. Okay, here's what I'm going to do. I'm going to get just a small amount of sodium acetate out here. Okay. So I've got just a tiny amount of sodium acetate here. Okay. So we're going to take and we're going to put a very tiny amount of sodium acetate in here. I'm just going to rake.
What is that? Ew, that's weird.
That
makes me itch. That's
It's the standard.
Okay, that's really just
My
weird.
skin is doing something.
It's growing.
That is so
Obviously,
it's making me itch.
My skin is
I want to see it in real life.
Oh.
Right there, dude.
Oh, it's going down.
Oh my god, it's blowing up the whole
I
thing.
want to do it.
looks like crystal.
Mutating.
Yeah, you put a whole bunch in there. It's a crystalline.
One crystal.
It's like in Superman when they brought the crystal.
Fortress of Solitude, yeah.
Can you take it out of there?
No.
Can you like take it out?
No.
Touch it. What if I drink it? Touch it. You'll die.
Is it gonna keep growing until all the water comes?
No.
I bit my lip.
Okay.
I'm ice now.
It looks like it, doesn't it? But it's not ice.
It's just frozen, right?
No, it's just a large crystal inside the water.
Is it
Is
cold?
it hard?
No. Shh, it's actually warm.
Is it hard?
This isn't hard, no. Okay.
I want to see this thing.
So listen. Listen very carefully. Yes, you can. Listen. Shh. Let me explain what's going on here. You need to write this description down so you can remember this is what this was. Okay?
Hang on one second.
This was a demonstration of a supersaturated solution. A supersaturated solution. Hello? Yes, ma'am. All right. All right. Okay?
Was that sodium acetate in water?
Yes.
It's for me.
Sodium acetate water.
Wait, is it Tate or Tate?
I wrote it down a moment ago.
Is it really my right?
No.
I mean, I was kind of busy writing this before the other thing.
Is that my guidance compass?
Okay, now the way that I tricked this, well, we're not leaving till I'm done, so leave your notes out and your pencil too.
So let him keep talking. Be quiet.
We're going to wait till you get your notes and pencil out.
Come on now.
You know what time it is?
What I did was I tricked the solution into accepting more sodium acetate than it ought to accept. And that's why once I started it crystallizing, it kept going. Once I started it crystallizing, it just kept going until it reached saturation. So this is now a saturated solution. So the part that is too much for it to handle forms these crystals. Okay?
Kept going till it got saturated.
Yeah. Now we've got this we've got these crystals in here. That's the part that's not dissolved. What little bit of water remains and what you can see in there is actually a lot of water, but you can't see it. What remains of the water is now saturated. Okay? So we tricked it, hold on one second. We tricked it into accepting more sodium acetate than it usually will take by heating it up and cooling it just right.
Is it like a thick substance?
It's kind of a thick substance, I guess. I mean, it's really fine crystals in there that if you shake it, it'll shake apart. They're real.
Take it.
That's holding up pretty good.
I don't think I can take so.
I want to
So
see
is
it.
it not like, what happens if you put it like a tablespoon?
Poke it.